Hi everybody, I'm really excited. Today I get to use this cool app I sometimes use called Explain Everything. So I can sit in the comfort of my own home and write videos for you guys. So today we're going to be talking about real numbers, number lines, opposites, and absolute value. And you should know a little bit about all of this already, but we're just going to kind of review. So first we're going to be talking about natural numbers. Natural numbers are the ones that I like to say you learned naturally, meaning when you were a little kid you probably learned the number 1 first, and then continued on with the whole numbers. So natural numbers start at 1 and they go on to infinity. The ... means goes on forever. Whole numbers were when you went to the grocery store and your mom said you wanted a piece of candy at checkout and she said you may have none. So we had to add in that number 0, okay? And 0 is a number. And so whole numbers start at 0 and work their way on. Again, they're whole, they're not fractions. Integers, my favorite type of numbers, are both positive and negative whole numbers. So -3, -2, -1, 0, 1, and continue on forever. So then all of these types of numbers are what we like to call rational numbers. Rational numbers are just numbers that you can write as a fraction. Any number you can write as a fraction. So integers are rational numbers. Natural numbers are rational numbers. Now there's also something called an irrational number. Irrational numbers are non-terminating, non-repeating decimals. We're going to learn about them in chapter 5, but you're probably more familiar with the one that that we talk about often, which is pi, okay? All of these numbers fall within the real number system, and that may seem funny to you, but there is actually another number system that you'll learn about as math moves forward. All right, let's move on. Okay, so why do we have these integers, and why is there a need for positive and negative numbers? Well, let's think about just these statements. A rise in temperature of 45 degrees, well, that can be represented by a positive 45, whereas a loss of $200 can be represented by a negative 200. So there is a need for positive and negatives because we do take things away from a value, and sometimes we're left with numbers that fall below 0. Let's make sure that we understand how numbers relate to a number line. So first I'm going to talk to you about that number line. The number line has a 0 right in the middle, and to the right on the number line are positive numbers, and to the left on a number line are my negative numbers. So I want you to think about that number line. Let's put these numbers in order from least to greatest. Well, the bigger the negative, the smaller the number. The bigger the negative, the smaller the number. All right, so the biggest negative I have is 3.75. So that in order from least to greatest, I'm going to put negative 3.75. All right, moving on, I see a negative 3. That's the next largest, so negative 3. And then I move towards negative 1. All right, 0, we're going to put 0 there. And then now I've got to decide between 7/3 and 2.5. One's a fraction, one's a decimal. I'm going to think about them both as decimals for a second. 7/3 is also 2 1/3. So that's actually a little bit less than 2.5. So there, I was able to put all these numbers in order from least to greatest. All right, let's see what else we can do. All right, we can also look at numbers, positive and negative numbers, and use inequality symbols to relate them. As a reminder, less than is a symbol that looks like that. I always say that this is like a point and like a sideways V. Greater than is a symbol that looks like that. So if I said to you, all right, tell me, -2, compare -2 and -5. Well, remember I said earlier, the larger the number, the more negative it is. So -2 is actually greater than -5. Now, what if I do something like this? -3 and -1. Well, the larger the number, the more negative it is. So -3 is actually less than -1. So sometimes when we're talking about negatives, we actually want to use inequality symbols to compare them. Opposites. Now, opposites, we often say a number is positive or negative, but I also like to think about it with the word opposite. Because if I put a negative in front of a number, that means I want the opposite. I'm doing an opposite operation. For example, I want the opposite of 7 plus 9. Okay, so the opposite of 7 plus 9 would be negative 16. 7 plus 9 is 16. Negative in front of it is going to make it its opposite. All right, so let's look at this one using the word opposite instead of negatives. I want the opposite of negative. I want the opposite of negative 1.8. Well, you guys have always learned that a negative and a negative are going to yield a positive. So this would actually be positive 1.8. But when you think about it, it is the same thing as me saying I want the opposite of negative 1.8. All right, so we want to be careful, though, when we evaluate equations and expressions with negatives. Here's an example. I give you an expression negative n plus 14 if n equals negative 8. Anytime you plug in values into an expression, you really should put them in parentheses. And in this case, it's even more important because that negative 8 has to go in just for the n, because it's telling me just n, not negative n. N is negative 8. So notice that I put a negative, I left that negative alone, I plugged in the negative 8 plus 14. So now we have a negative, or the opposite of negative 8, which is positive 8. So we have 8 plus 14, which is 22. Okay, so definitely be cautious. Be cautious when you're talking about those when you're evaluating with negatives. Absolute value. Last thing we need to talk about today, and I know you guys spent a lot of time last year working with absolute value, and anytime you see an absolute value symbols, these bars, okay, these nice little bars here. Oh, sorry, it's not looking so good here. You know that whatever's inside of it becomes positive. We take those absolute value bars and we make whatever's inside of it positive. So the absolute value of negative 2 is 2. Be careful, though. I could put a negative on the outside of the absolute value bars. That's different. First, we take the absolute value of negative 2, which is 2. But that negative is actually on the outside. So this is a case where I'd actually be able to get a negative 2. All right. The one thing that I want to be clear about is what I actually like as a definition for absolute value. Absolute value is really the distance from x, or some number, to 0 on a number line. Okay, so for example, if I said to you the absolute value of x equals 2, that means the distance from 0 to that number is 2. All right, so let's think about it like this. I could go 2 in this direction, right? But I also could go 2 in this direction, which would put me at negative 2. So if I was looking to find the solution, or what x could be 2 or negative 2. One thing we have to be really careful with absolute like this. The absolute value of x equals negative 1. I want you to think about this tonight, and we're going to talk about it tomorrow. I want you to think about if there's any number that you can make x, that when you take its absolute value, you're going to get negative 1. So that's the thinking for tonight. Hopefully, all these topics were review for you, and I hope you liked hearing me but not seeing me today on my Explain Everything app. And we will be reviewing and practicing this all tomorrow or Tuesday. Anyways, have a great night. Bye-bye.